At the end of today's lesson, you'll be able to create a quadratic equation and solve a geometry problem based on a verbal description. You will continue factoring and using the zero product property. Let's take a look at the do now. Create an expression for each verbal description below. The length of a rectangle is 5 inches more than twice, 2 times, a number. So I want to say that the length is 5 inches more than twice a number. So 5 inches more than tells me I should add 5 to something, and then twice a number tells me I can place 2x here. This is equivalent to 5 plus 2x. Okay, so now for the width. The width is 4 inches less than the same number. So now less than is a turnaround word. We have to change the order. So when it says 4 less than, it means we must be subtracting 4 from and then the same unknown number, x. Okay. For part A, we're asked to draw a picture of the rectangle and label using the expressions from the do now. So we have this rectangle here, and we're going to label the sides. The length is 2x plus 5, and the width would be x minus 4. If the area of the rectangle is 15 inches squared, find the dimensions. When it asks for find the dimensions, it's saying find the dimensions, meaning the length and width. So they want us to actually find the numerical value for the length and the width. Well, let's start with what they said here, the area. The area of a rectangle is always equal to length times width. So now, if the area is known to be 15 square inches, and the length is 2x plus 5 times the width, x minus 4, we end up with this equation here. It's not just a two-step or multi-step equation. It actually has many steps. First thing I notice is I can double distribute on the right side. So let's try it. Let's break apart this binomial. 2x wants to distribute to the x minus 4. So I'm going to rewrite that. Positive 5 would also like to distribute to x minus 4. But the entire time, this product is supposed to equal 15 square inches. So now let's solve it algebraically. I end up with 2x squared minus 8x plus 5x minus 20, and this is all equal to 15. Now, whenever we're solving equations, we should never get ahead of ourselves and think, oh, I should know the answer right away. Always ask yourself, what's one thing I can do to make this look one step easier? So here we end up with 15 equals 2x squared minus 3x squared minus 3x after combining like terms, and then minus 20. Now this is getting close to standard form for a quadratic equation. Standard form for a quadratic equation states I should have my ax squared term, followed by my bx term, followed by my c term, and it should all be equal to 0. This is not equal to 0. I want to get rid of this 15, so I'm going to have to subtract by 15 on both sides. Now I have 0 equals 2x squared minus 3x, and then same sign add, minus 35. Most of us are more comfortable with having our equals 0 on the right side of the equation. That is fine if you choose to place it there. Now we have standard form. It's time to factor. I check my list, GCF, dots, AC. There is no GCF. It cannot be dots, so now I need to use the AC method. I multiply A and C terms. I get negative 70x squared. I need to list all of my factors of 70. Right now would be a good time to pause, try it on your own, and then check your work through the factoring. Okay, let's check to see how well you factored. Here's my list. It shows positive 7 and negative 10x because they combine to a negative 3x in the center. In this group, my GCF was an x only, and I was left with 2x plus 7. In this group, the leading term was negative, so I factored out a negative 5 to be left with 2x plus 7, and then I glued back together this factor and rewrote my trinomial as a product of two binomials. Now, for solving, we use the zero product property. This factor times that factor must be 0, so either x minus 5 is 0 or 2x plus 7 is 0. In order for x minus 5 to be 0, that would occur when x equals 5, or for 2x plus 7 to be 0, I have to subtract 7 over from both sides and divide by 2, and I find out x could be negative 3.5. So now my final solutions would be negative 7/2 and positive 5. Of course, right now you should pause the video, take out your calculator, and substitute each answer. But wait, are we done? Let's go back up and see what was it that we were solving for. We want to know if the area is 15 square inches, we need the dimensions. Can I have dimensions of negative 3.5 and 5? No way. So instead of writing our answers this way, we actually have to reject an answer. I must reject this answer because it's negative. I cannot have a negative dimension. So now let's go back up to our let statements at the top, and this will help us solve for the length and width. If the length is 2 times x plus 5, and we think x is 5, that would mean my length is 2 times 5 plus 5, which is 15 inches. And then the width is x minus 4. So 5 minus 4 would give me 1 inch. And if I have something that is 15 by 1 inch, my area will be 15 square inches. So it's a 15 inch by 1 inch rectangle. Let's move on to problem 2. The instructions remind you that you should solve by making sure you have a picture or a key. You have to set up an equation, solve it, and then answer in a complete sentence. So here we have the length of a rectangle. So the first thing I do is draw a rectangle. Is 4 centimeters more than 3 times the width. So the length is 4 more than 3 times the width. Well, if I don't know the width, I could say the width equals x, and then the length would have to be 4 more than 3 times the width. Now the area again is 15 square inches. Different problem though. Here we have area equals length times width. We have 15 equals 3x plus 4 times x. If I distribute, I end up with 15 equals 3x squared plus 4x. This is getting close to standard form. So let's subtract 15 over. It has no like terms, so it is my C term. I end up with this trinomial. I've moved my equal zeros to the right side. It's now time to factor using the AC method because there is no GCF. This cannot be dots, so I must use the AC method. Now would be a good time to pause so that you can try your AC method and then check to see how you're doing. Okay, you should end up with x plus 3 and 3x minus 5. All of my work is shown. It's time for tea time. Now we set x plus 3 could be 0, or 3x minus 5 could be 0. Here I solve and I find x would be negative 3. However, I actually have to reject this answer before I even check it, because I cannot have a width of a negative dimension. So now let's solve for the other side. If I add 5, I find out 3x must be 5 divided by 3, and when x equals 5/3, then this factor would equal 0, yielding a trinomial set equal to 0. So my solution would be that the width is 5/3, or 1 2/3 of a centimeter, and then my length, I have to substitute this in. 3 times something plus 4. Our solution is 5/3. So if I put this over 1 and cross reduce, I end up with 5 plus 4 equals 9 centimeters. So my final answer here is a 5/3 of a centimeter by 9 centimeter rectangle. Okay, it's time for you to try the entire problem on your own. Pause it, try it, and then check your answers. Okay, your final answer should be that the rectangle is a 10 meter by 6 meter rectangle. Please follow your work, compare with mine, make sure you show all work, your T-chart and rejection solution as well. And if you have any questions, write them down so that you know and you're prepared on what to ask. Thank you for watching.